I'm Adam Tovell, Digital Music Curator at the BL and supporting the work of the Digital Music Lab project. And I'm joined today by Daniel Wolff, one of the project's co-investigators from the Music Informatics Research Group at City University, who's going to get a little bit more technical with you. But before we do that, let's look at a reasonably concise introduction to the project's goals, shamelessly pulled from our website. Digital Music Lab Analysing Big Music Data is a collaborative AHRC project between City University London, Queen Mary University of London, UCL and the British Library, funded under the Big Data call of the Digital Transformations in the Arts and Humanities theme. Our goal is to develop research methods and software infrastructure for exploring and analysing large-scale music collections, and to provide researchers and users with data sets and computational tools to analyse music, audio, scores, and metadata. Reasonably concise. So Digital Music Lab is one of 21 digital transformations in the Arts and Humanities project funded by the AHRC, as part of a £4.6 million investment in big data. So a huge recognition of the potential for making large and rich data sets more accessible and easier to interpret by the public, and of the benefits this data can bring to research. Now, when we think about big data, recorded music isn't something that immediately comes to mind. Unlike text and images, which we can read or see and quantify and without too much trouble understand, sound has, until relatively recently, remained slightly less accessible and slightly more opaque. Today, however, technology is such that we can apply the same techniques that support the mining of information from more traditional media to recorded sound collections, and this is what Digital Music Lab is all about. So, condensing my rather lengthy description, the project objectives are to develop and evaluate music research methods for big data, to develop an infrastructure that's technical, institutional, legal for large-scale music analysis, to develop tools for large-scale computational musicology, and to use and produce big music data sets. Today, music research is moving toward data-oriented, empirical methods to answer questions about things like composition and performance. And this approach can benefit from computational methods of inquiry. So, using digital sound files, music researchers can use audio analysis and processing tools like Sonic Visualizer. I'm sure you can all recognize a visualization of Dire Straits. To extract objective data on features like timing, so the points at which a pianist presses a key, dynamics, how hard those keys are pressed, intonation, how their instrument is tuned, alongside features of composition like chord progression or melody. And the results of this data extraction, the derived data from software analysis, can then be used to inform or to answer specific research questions. Thus far, however, this approach to musicology has been limited to relatively small-scale sound collections, using relatively manual processes to extract information from digital sound files. Now, conversely, researchers in music information retrieval, MIR, have begun to explore the use of music analysis tools across large data sets, particularly in commercial applications, exploring things like acoustic similarity between sound recordings, music fingerprinting, and automated identification. So users of some of today's streaming services, Spotify being an example, benefit from this research in features like music recommendation and playlisting. Through data from large-scale analysis, I can choose to listen to something to suit my mood, or to discover new music based on my previous choices. Now, while there are differences between the terminologies and the methods and the goals of music information retrieval and musicology, there are areas in which the work of one can benefit the other. If enabled to use software tools to extract information from large corpuses of recorded sound, music researchers can ask more complex research questions, like how performance style changes over time or between locations in relation to a particular work or genre, or what influence a particular composer or genre may have had on another. In today's digital research environments, big data presents fascinating opportunities for music research. But to make this approach possible, researchers need access to large collections of digital sound recordings. And that's where the BL comes in. Digital Music Lab is a collaborative project bringing musicologists together with computer scientists and, importantly, content holders. And by doing that, bridging the gap between musicology and music informatics. So, for example, let's say I have a particular interest in Chopin, or more specifically, his Nocturne No. 2. Now, using existing methods and tools, I could analyze as many different recordings of this work as I could find. So I could find them, could acquire them, open them up, extract the information that I wanted, interpret that information, and form some conclusions. If, however, I had access to more than 400 recorded performances of the work, as the BL does, given by different people, in different places over a period of more than 100 years, then the questions I can ask are potentially far bigger. So how might performances of Chopin's work have changed over time? Has the style of one performer influenced another, or does performance style differ between locations? To support the aims of Digital Music Lab, that's the development of new software tools for music analysis and the development of research methods for big music data, the BL will, along with other project partners, which Daniel will tell you a little bit more about, provide researchers with access to large, curated digital collections from our archives of recorded music. Why the BL? Well, we have a lot of it. So the BL is the custodian of the nation's recorded sound collections, and we have vast sound archive at our fingertips. Over 3 million unique music recordings, of which an ever-increasing number are now digital. Our collections are wide-ranging, covering all genres of music, from pop to world and traditional through to classical music. And our researchers range from ethnomusicologists to composers, conductors, performers, academics, and the curious public. They're well described. Our catalogue holds over 3 million detailed records of recorded performances in our collections. That's a number which I hope is continuing to grow as we speak. And we are also in the happy position of having the legal right to make these sound recordings available to all those that wish to use them. Now, that might be off-site through our online gallery at sounds.bl.uk, curated collections of 50,000 items from across our recorded sound collections, or on-site in our reading rooms. So, using digital recordings from our extensive collections, researchers will be given access to a wealth of material to enable the large-scale analysis of recorded music. And the results of this analysis will, where possible, be made available to the research community, enabling reuse and further collaboration. Hopefully that gives you a reasonable overview of the project's whys and wherefores. So I'll hand you over to Daniel Wolff to explain a little bit more about the technical aspects of the project.
Thank you, Adam. So at the outset of the project, we hosted a workshop to identify some of the musicological questions which would inform and steer which kind of tasks we want to be able to solve with our methods. Some of those Adam has already mentioned, so people were interested, musicologists and music enthusiasts were interested in automatic analysis of scores. And the BL also has a collection of scores and digitized scores, which we want to include. Also, structural analysis from audio, so from all the audio recordings, for example, repetitions of an exposition, how they appear during a recording, if they appear at different places in different recordings. Analyzing styles and trends over time to derive new similarity metrics, to find pieces which are similar, or to find performances of pieces which are similar, for example, having the same performer, or to distinguish different performances of a piece based on the performers. Also, we are interested in working across different heterogeneous collections, so combine different collections, for example, the British Library and others I will mention shortly. And finally, being in a time and age where we have plenty of information also available via the web, contributed by users or by other organizations, we want to utilize external metadata and include them in our workflow. The data sets we use at the moment include the one from the British Library, where we're still adding and curating available music data into our current processing. Currently, we've analyzed over 40,000 recordings, and this collection is growing. We also are analyzing the Charm data set, which contains over about 5,000 copyright-free historical recordings and metadata, as well as data from the I Like Music company, which provides a commercial music library of 1.2 million tracks, and also a quite large production music library. So all these three data sets are quite heterogeneous in the way the metadata is displayed and the type of metadata which is available. And one of the goals of the DML project is to integrate these data in a common workflow which may be able to help musicologists answer bigger data questions. For the results and the analysis we've performed on these three data sets, I'll talk a bit more about the chord detection we've done on I Like Music, which enables us to look at collection-wide information in the music. For the Charm data set, we have done instrumentation analysis, so is there a piano solo piece or not, MIDI scale transcription, and a high-res transcription from the acoustic recordings to scores which are symbolically and also readable by musicians. And finally, we've done most of this analysis, so MIDI scale, high-res transcription, key detection, and chord detection, as well as speech versus music segmentation on the British Library dataset, as this dataset also contains some speech. This is an example for automatic music transcription. So we would start with an audio file, which is basically shown on the top and which shows the sound pressure levels over time, and generate an intermediate description of this audio file where you can see orange bars which already indicate some of the transcriptions and the notes which are occurring in the piece. And finally, what we generate is a score, and this is automatically generated from the audio recording, which then can be used for further analysis or just visualization to the musicologist. Also, for chord detection, this is an example where we have an audio piece which is annotated with different chords. So this is a D6 chord, A major chord, D major chord, and then it ends with an A minor chord. And we've extracted all such chord sequences from the I Like Music commercial dataset collection. Using a VAM plugin and parallel processing, we were able to process these over 1 million pieces in 6 weeks. And this led us to a visualization which we've developed in the DML project as well, which now can show different chords. So maybe this is too small to see from behind, but these are different chord descriptions. There's the tones the chords is based on are written on the outside, and then the type of the chord. If it's a minor 7, major 7, minor, major, or dominant 7 chord are depicted on the inside. And the lines in this diagram show how frequent certain transitions from one chord to the other appear. We've also developed a series of these visualizations, which are all available on the website, which you find on the right side of the slides, dml.city.ac.uk. And this is the kind of collection-level analysis we want to get to. Another thing we've developed is automatic tagging procedure. Tags are very important. Tags are very important in order to identify a music piece, to browse collections due to genre, style, and period, and not all of the music collections which we have access to are tagged in a consistent way and in a flawless way. So we thought about using automatic classification to enhance those tags and to add tags where they are missing. We've used an incremental tagging techniques, which allows us to reduce the number of training examples and actually manual annotated tags. And on the charm data set, we showed that we can reduce the amount of tags which actually units have to provide for the music by 87%, by still giving a classification error of less than 2%. So we get very good tagging results with minimal human input. We've also developed a collaborative interface for this based on the Casimir framework, but I'm not going into detail because we're short on time. In future, we want to do some analysis of audio. For example, score to audio. We want to analyze scores further, and we want to do more collection-level analysis. At the moment, we will then have a web interface which collects two collections, the British Library collection and the I Like Music collection, through a web interface, allowing for the derived metadata, where possible, to be available all over the world. Our project is determined to be scalable so that we can use more data processing, sustainable, by providing most of the code where we can as open source and reproducible, so similar systems can be set up at different institutions. So to conclude, the DML project provides and wants to provide methods and infrastructure for analysis of large music collections, to be able to access larger data sets, enrich metadata, and make comparisons on a large scale available. We provide a web front-end and software tools, and the project also pioneers the collaborative and methodologically framework which is which is needed for this kind of big data questions. Thank you very much.